Hey, welcome to this lesson on the remainder theorem. The student objectives for this lesson: use the remainder theorem to find a remainder without actually dividing, and to extend the remainder theorem to find factors of a polynomial. And the essential question: do I really need to divide every polynomial to figure out how to factor it? And below you'll see the Common Core standards. So here's what we know. Some polynomials can be factored using greatest common factor, difference of squares, factoring by grouping, etc. We can divide polynomials using long division or synthetic division. And if we get a remainder of 0, we can rewrite their polynomial in factored form. What the remainder theorem tells us is if I have a polynomial division like the one you see, 8x to the 7th power plus 6x to the 5th power, plus blah, 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 all the way down to its constant term, and I divide that by another polynomial, x minus a, instead of dividing and going through all that work, if I want to know if x minus a is indeed a factor, I can take that a, or what would eventually be my root, and I can substitute that into the polynomial. If I substitute that into the polynomial, and so wherever I see an x, I substitute an a in there. If I plug that in and my polynomial is 0, then it is indeed a factor. Why is this so? Well, if you think about it, what are we actually doing when we're finding the factors or the roots? So if you think back to finding the x-intercepts of a quadratic equation, you would usually get something like this. Let's say x plus 2 and x minus 3. I would set them equal to 0. When I set them equal to 0, I'm really saying what is the x value that will make this polynomial equal 0? And then I would solve and I'd get x equals -2 and x equals 3. Those x values would make my polynomial 0. So if I substituted the x back in, I would ultimately get 0 as my answer. Well, that's what the remainder theorem is doing. So just like if I had a value that made the polynomial 0, well, I could take that, I could put it in the form of x. So if I added 2 to both sides in this instance, and I got x plus 2 equals 0. Well, that x plus 2 is a factor, like we had already stated. So that's what the remainder theorem is telling us. And we can apply that to any polynomial, not just quadratics. So here's an example. In the problem, and here's our problem right here. In the problem, the remainder is 4. So let's use the remainder theorem to see what the remainder would be. So remember, it's a. It's in the form x minus a. So if I have x plus a, it's really equal to x minus a negative a. So since I have x plus 1, it's really equal to x minus -1. So -1 is what I'm going to be substituting into my polynomial right here. So -1 squared plus 3 times -1 plus 6. And if I do that, I'm going to get 1 plus a -3 plus a 6. 1 plus -3 is -2, and then adding 6 to that, I get 4. And that is, in fact, my remainder. So here's an example of a problem you might see. Now before we start, I just want to clarify this p of x. And usually you see either y equals or f of x equals or something like that. F of x means it's a function. The reason why you may see this, p of x, is because it's simply just telling us that this is in fact a polynomial. So it's still a function, it's just a more defined function as of a polynomial. So that's where the notation p of x comes from. So I'm going to take my polynomial. So what is the remainder when you divide p of x by x plus 2? So pretty much x minus a negative 2, it's going to lead us to what is p of negative 2. So that's what this question right here is really asking me. What is the remainder? Or, using the remainder theorem, what is p of negative 2? So, if I write p of negative 2, so if on the left side I put a negative 2 where the x is, so instead of p of x I have p of negative 2, then on the right side I better put a negative 2 where the x's are. If I solve this out, 2 cubed is 8, and don't forget it's negative 2 times negative 2, which is positive 4, and positive 4 times negative 2 is a negative 8, plus 4 times negative 2 squared, which is 4, minus 8 times negative 2, which is going to be positive 16, plus 6. So if I solve this out, negative 8 plus 16 plus 16 plus 6. Negative 8 plus 16 is 8. 8 plus 16 is 24. 24 plus 6 is 30. So the remainder for this polynomial is 30. That's all for this lesson. Make sure you go back through the video and rewatch it and really clarify what was being taught. Go ahead, try your homework assignment. If you have any questions, feel free to reach out to me on BBIM, text message, or phone call. And be sure to come to live class so we can go through this a little more in depth.